Step one is make the timeline. Okay, which process is coming in first here?
P1.
No, look at the arrival time. Which process is coming in first? Which one? P3 is coming in first. Right? Then who's coming in next? P1 is coming at. Then P5 is coming in at 4. And then P2 and they're both coming in at 7. And what is this queue called? So this is the FIFO queue. All right, step 2. Any questions here?
No, sir.
All right, P3 starts running. For how long? What is the burst time for P3? So here you put? And then who comes in? P1. All right, runs for how long? What should be this mark here? What is the value here?
8.
This is 8. Make sense? You can make this into a box if you want. All right, P5 runs for how long? 4 seconds or 4 milliseconds, whatever the unit is. So how much is that? Yes or no? Okay, now P2 comes in or P4?
First.
They both, but they cannot run together for now. So remember, P2 comes in first. Whichever has a lower number will come in first for these problems. And then P2 runs for how long? Is it 4? Yeah. And then finally P4 runs for 2, right? What is this number here?
16.
And this is? And this is your
Total time.
total time. Let's do step 3. So processes, arrival time, burst time, completion time, then
Average waiting time.
turnaround time and waiting time. Okay, now what is the order here? It's not the same as given. What is the order here now? So it's P3, P1, P5, P2, P4. And what are the arrival times? 0, 3, 4, 7, 7. Is that making sense? What were their burst times? 3, 5, 4, 4, 2. Or if you're fasting and if you need to go, you can go now. Okay, if you're fasting and if you have to break fast. No, Jada, we're not fasting. What is the completion time for P3? 3. You guys fasting? What is the completion time for P1? 8, 12, 16, and
18.
let me just check. Okay, what was the formula for total time or turnaround time? Completion minus arrival. So this is 5. 16 minus 7 is
9.
Does that make sense? And what was the formula for the waiting time?
Waiting time is turnaround time minus burst time.
Turnaround minus burst. So what is the waiting time for P3? Any questions there? Okay, take the sum of this, take the sum of this. Tell me how much.
Turnaround time 36.
36?
And waiting time would be 18.
So now step 4. The average waiting time. How much? 36, no, 18 divided by 5, right? So how much?
3.6.
And what was the other one? Average turnaround time?
Time used divided by time taken.
No, we're doing the average turnaround time. 36 divided by
7.2.
2. And efficiency here is there any time wasted? Is there any time wasted?
Yes.
Which point? Is there any point where the CPU is not in use?
No.
No. So the efficiency will be 100%. So the average waiting time, is this high or low compared to the previous example?
It's higher.
No, the previous example that we did, what was the average waiting time? 11. And here it is? Why do you think that is? Can somebody think? Look at the two problems. Tell me why this is less.
Because the first process was very long.
Very good. Because if you look at the previous example,
In the flow, like from zero lower to high.
if you look at the previous example, who's it? If you look at the previous example, the earlier process had a very high burst time. So make a note, if the earlier processes have high burst times, this becomes a non-efficient algorithm. We're getting a good result here because they are all kind of distributed evenly, the burst times. You just make a note for this algorithm, if the initial processes have high burst times, then that makes this non-efficient. Okay, and this is the first algorithm we learned. We'll do more next week. Now go to Blackboard and try to do at least one on your own today. Stop recording.